Hello and welcome to our second C00C00CON conference. Today I will be a host. My name is Leonid, and let's start our conference. Today we have a range of topics, starting from defense and some with offense and some practical presentations. And our first speaker, Denis Kutin, will tell us about vulnerability management. So welcome, Denis. Please take a place and we can start.
Thank you guys. Thank you guys for having me, for inviting, and let me speak. Allow me to speak about some of my pain. So I think that this would be useful for me to share with you some information about vulnerability management and provide for you some info about the topic. So we will be talking about vulnerability management. Specifically, I'm scoping at the infrastructure layer. Now, since unfortunately we don't have much chances to know each other, small information about me. I've been Orthodox Blue Team for 10 plus years. I've been doing mostly log management, vulnerability management, access control, security review. So I know a thing or two about these topics, so I'd like to share it with you and probably provide you maybe some insights or perspective from the Blue Team perspective. Now, as I mentioned before, we've been talking about infrastructure layer, but sometimes it's hard to define what exactly infrastructure, because as you probably know that infrastructure, it's some code that was written previously, but now you are using it. But still, in most companies, in most enterprises, there is a layer of infrastructure which basically includes bare metal servers, virtual machines, network devices, client endpoints, and probably you can say that infrastructure as a service or platform as a service also might be infrastructure, but there is some notes about it which I probably will add in the end of the presentation. Now, as I mentioned, we are building the process here, so we are interested about to make something out of the vulnerability management. What it means from the vulnerability management perspective. Like probably you might know from cybernetics that process is some kind of a black box which you have something in as an output, is an input and something as an output. In case of vulnerability management, it's pretty straightforward. We have some vulnerabilities in our infrastructure. We want to have no vulnerabilities in our infrastructure. Kind of easy said than done. Well, we will see how it goes. Now, as a process organization, we will look into it as a three steps entity or whatever approach. With the identification, classification, and remediation part. And we are going to start with the identification part of the process. And I'd like to start with some basic things, but I hope I will explain why these basic things matter in reality. So before we start to do vulnerability management, we need to understand what vulnerability is. And here's where the problems get started. So I prefer to tend more kind of classical or old school approach where vulnerability defined as a state of informational security which can possibly lead to compromise of classical information security CIA thread, where CIA stands for confidentiality, integrity, and availability. So I like this approach because as a theoretical understanding, it allows you to think about information security in general, how it looks and what are the connection within each points or each areas of information security. In these particular cases, the possible state of the compromising allows to go to the wait a second. Yay. So this allows to go to, for example, risk management. But this approach also has its disadvantages. I hope I will give you the insights about it a bit later. So Wikipedia approach, they are only gathering a lot of information security standards and policies and trying to define vulnerability in more sensible and human understandable approach, where they define vulnerability as a weakness that can be exploited by a threat actor and the main point for the crossing privilege boundaries within a computer system. Well, it sounds a bit more understandable for a person who didn't dive deep into information security. Here's another approach which I faced maybe 1 or 2 years ago. So this is a definition which was provided to me by one of my ex-colleagues. So he defined that vulnerability is something that can provide intruder some benefits, where benefits he defined with these examples, like gaining personal data, allowing to have an RCE, or some ability to damage a service. So basically the main point for that was that it has some kind of an impact. So this is a very practical approach where you try to define vulnerability from actually some problems that they might cause in your infrastructure or in your code. So now here's the thing, right? So the problem which I tried to explain here, that even when we're starting from the basic, when we're starting to define what vulnerability is, we are facing that it's a complex entity. On one hand, it's a kind of a contradiction between a state of a system, which seems to be going from within the system, but on the other hand, it's kind of like an impact which seems to be comes from out of the system. So that's a problem, and it's a different aspect, and I suggest you to think about it as a different aspect of vulnerability, which you want to focus depending on what you are doing specifically in information security. And why you need it? Because basically vulnerability is a building material for everything that we're doing in information security. We either looking for them, we either try to prevent them to happen, we either investigating how they appeared in the reality. So we are mostly interested in these type of things. Okay, so we've got this knowledge, but let's try to understand how can we find vulnerabilities. So the most straightforward approach is to using so-called mechanism CVE, which stands for Common Vulnerabilities and Exposures. You can look the website here to check how it looks and what it's about. Basically, their goal to identify and define and catalog publicly disclosed cybersecurity vulnerabilities. In most cases, most nationals have something like national vulnerability databases, which allows to store these catalog and adding some additional specific analysis for the vulnerabilities that have been discovered. Specifically, in these cases, we're talking about CVE and CPE, which they try to connect with weaknesses and program where these vulnerabilities have been found on. So I'm not going to dive into here deeply. Try to open the sites and learn by it yourself. So this is the way you can gather the information about vulnerabilities, but you also need to identify that these vulnerabilities are present in your environment, specifically in your infrastructure. So maybe about like 7 or 10 years ago, the most common thing was about manual finding solutions, where we as a security engineers try to read some mail lists of some softwares that we've been using, try to understand what the POC were submitted there, or what the information was public there. So, and try to make some kind of a script to test the environment by ourselves. But this was long time ago. Nowadays, these type of tasks can be automated with different scanners, which basically do this for us. where the initial step for this item will be done by different vulnerability analysis or different type of vulnerability analysis that came from code analysis that I was talking about before. So mainly in the modern infrastructure, you will stick with scan with the credentials, basically with root credentials you want to use it, and sometimes with agent-based scans. So how to define which scans should be used on which target? So here's a suggestion which you can use. For some non-credential scans, you can use this type of scan for some external assets which available to you, which you have in your company. Maybe some kind of a services available, maybe some public IP addresses, domains. So you can start with some simple version grabbing technique with enumeration of software and version that used in the environment. Here's an example. You can start with VPScan if you are using any WordPress as a site, or there is also some more solutions that provide you more to build more robust attacks and patterns, like OpenZap, for example. Also, non-credential scans can be used for such type of assets in your company as bring your own devices, when you have the employees' devices that been added into your as a part of a work process. Difference between credential and agent scans basically based on the perimeter. So if you are still under the perimeter, so you can go with the credential scan. If you are out of the perimeter, you can and probably you should use agent-based scan. So the main pro and cons between credential scans and agent scans are listed here. Basically, credential scans, easy to maintain. You just write a playbook, GPO policy, a script to deploy one user, to provide him a root admin accounts, and just do the scanning. This might be a potentially security concern because you are having only one user to rule most of your infrastructure. There is some technical way to overcome this, but in my experience, for example, Labs, which is famous Microsoft solution to local admin password something, basically to separate, allow user to have his own, allowing admin user to have their own password for the escalation. And also with credential scan, you cannot reach remote devices because basically you are asking a person, an employee, to have an access to their devices via internet, for example. So this is where agent comes. They can, in most cases, they can only be the way to reach such devices. The drawbacks here that it's a bit of a hard to maintain such things. You need to add the agent into golden image. You need to take care regularly update it with version when there will be some vulnerabilities found in the agent. So it's a bit of a headaches. So you need to allocate some resources for that as well. So we've got a bunch of vulnerabilities in our environment, right? So we have found a problem for ourselves that we need to deal with. Let's try to understand what exactly we have found, how the problem is the big one. So vulnerability scoring is the first thing that came into mind, that we need to try to distinguish different vulnerabilities, how critical they are. So from my perspective, from my experience, you could use the vulnerability scoring within the two main areas of the scoring. So one is the objective and the second is the subjective. So objective, it's just like an abstract thinking about how problematic or how critical the vulnerability can be. And right now, at the moment, there is only one approach to categorize vulnerabilities on a open source base, if I may say so. So this is the CVSS scoring. At the moment, there is a version 3.1. They are preparing to release 3.0, so they are preparing to release 3.1. So this is an initiative where they try to make a simplified way, some kind of like a understanding how problematic this vulnerability is. So in this specific case, they are giving you a simple number like 5.3, which they are defined as a medium severity. But there is a kind of big mathematics or calculus behind this, where different experts defining how the problem is the big one, what is the impact on the confidentiality, integrity, availability, but they go beyond that. They also try to define some things like attack complexity, privilege requirement, user interaction. So there is a kind of interesting things going there, and that's only one metric, base score. But they also have a temporal score. There is also environmental score. So they try to make it as much as complex. Now, if you go with some security vendor who provides their knowledge or their know-how to categorize this, you also might find that there is some. For example, Tenable has a VPR, or Microsoft has their own way how they define and redefine the severity of vulnerabilities of their scoring, despite the CVSS initiative. So this is pretty understandable and pretty easy to read metric. So the main question, the main problems go with the subjective one, right? So we have log4shell in our environment. When we should fix it? Should we fix it tomorrow? Should we fix it on the Monday with morning coffee? Or should we forget about it for 1 year and then been hacked? But anyway, so this is the subjective part, and this is which I think that this is basically why I get paid for. Because it requires for you to some understanding what's going on in the environment, in the infrastructure. You need to have a discussion with the team, how they think and what they think about this one. There is also some initiative where the vendors try to do the formalization of this part, but I would say at the moment it's kind of not very mature, so they just only exploring this area. Now, this is an example of how we define in the company what are the asset critically, how we are defining criticality of the assets. So you can try to use it. The main problem that you can define it, but the main problem that you need to go with this categorization. Go with this categorization for to the bottom of this. So, for example, for me, when I made this presentation, I figured out that I'm not doing good job for the non-essential part, and I will show you this a bit in a moment. So the thing is that at least you need to have something like this to understand what you expect to be essential or a critical. You may want to go with the 3 items, with 4 items. It depends on you, but this is the kind of where you can start. You can use this as a starting point. Okay, so we have found the problem. We even try to understand how the big problem is, how the deep bottom, how the deep pit, how the deep pit is this. Let's try to understand how exactly we can deal with this problem. Now, the funny thing that I found in my experience, that you need to have a formalized process that never be followed by anyone, neither by your team nor by infra team or even by employees, but you should have it because it will allow you to understand by yourself what you want to do from yourself and from infra team. So this is an example, right? If you remember, we started from the black box, and this is what is in the black box, and it's only just a small part of this black box. This is the input of the black box. This is the output of the black box, and probably you might guess that this block scheme was written by a security guy, because most of the actions are happening on the infrastructure team. So, but at least, so we started with this. We understand that it's undoable, that it's impossible to follow to it, and we switched to another approach with more kind of like agile agile thing with 1 week's meetings. So we admitted to skip Jira, for example, with creating tickets. So we do it on a weekly basis. But again, so when you started, you would have the understanding what you expect to do by yourself, what you want to expect to done by IT team, what do you expect even to do with employees, because you might want to do a shift left and put some burden of dealing with vulnerabilities on the employee side and implement some, for example, zero trust policy where employee cannot access corporate environments if they have any unclosed vulnerabilities on their devices. So that will give you an understanding of this. Now, the second item which I recommend you is to establish some timeline. So this is where the magic happens, right? So the magic of going from the vulnerability management to risk management. So basically we have risk scoring of vulnerabilities, we have asset criticality. So what should we do with this? That they provide any problems, that they generate any risk for our company? Well, we're assuming that they do, and we would like to remediate, we would like to deal with this with risk within this time frame. So this time frame, thank you, Siri. So this time frame rate was taken from some Australian government recommendations, which I don't remember exactly which one. I just Googled it and thought, oh yes, Australian. It's the second favorable English speakers after the Irish. So probably we should follow with the Australian recommendations. But in reality, right now I see that, for example, in production we're doing a good job with this remediation time, but it's in corporate, it's a complete mess. So probably I want to raise this time for the corporate side, so we won't look so desperate there. Anyway, so but probably you are guessing, what about actual remediation, Denis? You are talking about the process and everything like this, but how to do the actual remediation? And the problem here is that there is no silver bullet, and it's a very straightforward and very monotonous and routine engineering task, which is starting from you are logging in into device, you are doing the update, you are applying the secure configuration. So pretty straightforward, pretty understandable. Several cumberstones which probably might give you a headache for your team. Now, first of all, you need to understand who and how will deliver this patches or secure configuration. Who is the owner of the asset? Who is the person with whom you need to contact about this problem? So I will talk about it a bit later. So this is the problem, right? You want to be a person who are interested in a good CMDB or in a good asset management database. Second problem that you probably will face, it's a reboot. So reboot, it's a quite expensive operation, specifically for the production. Good thing it's in production, it will require it only when the, in Linux world, when the kernel is updated, which more or less often happens. So probably you want to go with some maintains time frame, and you want to discuss it with the team, like, okay guys, how often we are doing reboots? Can we do it with the high availability part, or we are not anything to or we need to have a downtime for these things. Also, this would be a problem for the corporate side. You need to gain some of the trust from your users, so they do not fight or do not against of the reboot part. Legacy. This is another big deal of the problems within vulnerability management. You need to have a dedicated streamline for discussing the legacies. Just deal with it. Foster an automation culture. That might be a problem, but sometimes you might see that there is a problems that the people do not want to automate specifically the patches delivery. So you might want to be a guy who are always try to understand how this monotonous job can be automated. Well, and the next thing is kind of like a motivational. I guess this is why we're here. well, not for me, but anyway. So the thing is that you might need to go beyond the expected actions. What it means? So you need to be kind of like a technical leader for the remediation delivery part and for the vulnerability detection part. So for the remediation and delivery, quick example. So last year I had some discussion with our infra team where they didn't know how to automate Google Chrome updates, and when I asked why, they were assuming that they cannot do because it's only available for Active Directory machines, because you need to deploy a specific group policy. But so just Googling about how to deploy group policy locally and share it with the team, so they go, oh, okay, so this is new to me. Sorry, I need to read something about it. So stupid, but you might face this. For the vulnerability detection, so this is an idea or kind of like a thing that the problem with this part of processes that you can go deep into building the process and forget about what exactly you're fighting for. So sometimes you need to have some examples exactly what you are doing, why we are fighting RCE, why we are fighting a local privilege escalation. Well, because they are actually a thing, so you might want to go beyond that and try to investigate it and try to run it, maybe involve your team and create some kind of a small CTF for them, or small example of how this specific vulnerability can be exploited in your environment. And here's some quick advice for you. So if you will not have anything to do after this meetup, you can go and look for this playlist, where I think there is a good propaganda of a security approach when the vulnerability was found and the person asked himself, how can he find this vulnerability by himself or by his own? So just a quick sharing of a good information with you. Okay, so these are the useful metrics that we are using right now, and feel free to implement some of them, or try to think about these next things. Now, first of all, you need to understand what is the coverage of your assets. So we're doing scans, right? We try to understand what our infrastructure is, how good we are in that, how clearly we understand that, yes, we're covering 100%, no, we're covering like 50% or something like this. Second thing, which is also recommend for you to check, it's the assets inconsistency check, or system cross-reference check. So for example, you do have an asset management base, you have, for example, some VMware or OpenStack deployed, so you want to dump the data out of it, check what we are covering with our vulnerability management, and then goes vice versa, what we have in our vulnerability management and how much does it cover for our asset management or for the OpenStack, whatever you've got there. Now, the next item you want to check is the scans regularity. In small companies, it's a not big deal. Basically, you're doing it on a daily basis and you're fine. But in some cases, you might have a situation when you can do scans only on a weekly basis, on a monthly basis. So you need to also be aware of this situation. Now, this is the third item, agent visibility. This one is specifically if you are going with the agent, so you can do the good coverage with the assets and with the agents, but these agents might be offline. Now, what is the reason behind this? Why they are offline? Because they were stolen, because an employee has left the company, or because they are just offline because he is on a vacation. So there might be good cases, there might be bad cases, but you also need to understand this. And the last two is the most important. So as you probably might notice, these four metrics, it's kind of supportive metric. You are not interested in them as in vulnerability management process. You are interested in them only because they will allow you to be more successful in the vulnerability management. But for the vulnerability specifically, I recommend to go with metrics like the overall amount of vulnerabilities distinguished by the severity and time you are spending to remediate these vulnerabilities. So let's try to summarize what we have learned today, right? So some key takeaways that you might take from this presentation. Now, first of all, if you want to have a successful vulnerability management, you need to have a successful asset management. So there is no other way you can deal with this. You need to have a clear understanding of what life cycle is in your company implemented, so then you can follow with this life cycle for the vulnerability management. So here, in example, in the previous slide, I mentioned some metrics that we're gathering here, but there is also one which which I didn't have space to make the screenshot for the garbage collector. So we are implemented some kind of like an automation to delete some assets that been put on a shelf. So this is connected to the asset management. Now you need to have a technical leader for the process. Either it's you or it's some other person, but you need a person who understands how can we remediate, how can we automate the remediation, what exactly we're dealing with, what is the impact is about. Automation is your bliss and curse. Well, as it said, you need to do this, otherwise you cannot, otherwise there is only extensive way for you to go more or less, to pace up with the vulnerabilities that you are getting, but also it's a curse because it requires additional resources to support. Several documents that make sense to the team. So this is where I started. You have the process. You define the process for the asset management. You define the process for the asset criticality. You define something that risk management. Pretty easy. Every dumb security engineer as myself can understand this. Make metrics actually work for sake of your process. So as I said, like we do a lot of, you will do a lot of metrics, but why you are doing this? Because you want this process be successful. So that means you always need to understand what goes behind these, what goes exactly behind these metrics. So not only you look into them, but also the team look into them. And of course, you want to deliver the results to your management. This is basically what I was talking about, the previous two metrics for the time remediation and the asset criticality. You are wasting, you are spending, you're asking people to work on this. You are spending your time to work on this. So basically, that's something that's done for some reason. So if you think that it's not a part of an enterprise, then probably you shouldn't do this. If you are doing this, so then try to make this make sense for you and for the management part. That's what I wanted to say, but I also have a few more slides. If we have time, if I didn't chew up much of the time, I can go for that. What do you say?
Yeah. Let's do it.
Okay, let's vote. Let's vote. Denis, you're too boring. Stop.
No.
Okay. Denis, please continue. I was sleeping during the presentation. Okay. Now, first of all, this is kind of like half funny thing. So probably you know that there is a concept for infrastructure as a code, which right now try to be paced up by concept security as a code. Basically, people right now engineers try to invent everything as a code. And the funny part about it, despite that they goes with trying to define the state of the system in a code, but still there is once in a while you probably will see some backward compatibility. So here's an example of Docker image where people just deployed a classical Ubuntu image where they try to install classical apt packages, dep packages, and basically despite the pinning part, the way how can you overcome the problems in such environment is just using the old school approach to deliver the unintended upgrades for Ubuntu specifically with this package, so you can run it, and probably it installs security updates and break your production. But hey, no vulnerabilities. We're good. We're doing our job. This was the first item. The second item which I want to share with you, it's about this paranoid approach in security that you shouldn't trust anyone. And here's a good example which was published by, I think, maybe like 1 week ago or something. You can read it. You can check it here. So this example is showing how the different security vendors treat vulnerabilities. So different security vendors has different set of vulnerabilities. So you might want to use several vendors if you'd like. But that's not only the case. There is also a case that, as I mentioned, there is a NVD, vulnerability database. So here's the coverage of the security vendor by the overall amount of vulnerabilities. So you kind of be aware of this, and that's why you might want to double check that yes, everything we have deployed in our infrastructure is covered by our vendor. But this rabbit hole doesn't end here. So even NVD and CVE doesn't provide you a good amount of coverage for the vulnerabilities. So according to another security vendor, so they are claiming that there are around Kuman, how it will be in English, 900,000 vulnerabilities missing from CVE records. And most importantly, last maybe 2 years, I heard constantly some criticism of CVE, and here's a good example of this criticism from the open source community, where they are telling what is the problem with the CVE. Basically, they are claiming that their CVE or MITRE organization, they are providing a CNA status. CNA status, it's a status allows you to submit CVE scores. So it's provided to vendors, but it's not provided to people, it's not provided to community. So you cannot, as a security researcher, just submit a CVE. You need to submit it to a vendor, and then the vendor make a decision, oh yeah, that's important, probably I should release it. So you might guess with your paranoia here, would vendor do a good job about it? So anyway, so you can read about this criticism here, and yes, and that's all that I wanted to tell. Thank you very much for your attention.
We get into our next topic, and today, for our next topic, Andrei Krutikov will present about vulnerabilities in smart contract, so getting from more defensive approach to more offensive approach. Let's welcome Andrei, and please start with your presentation.
Hi. So my name is Andrei. Today I'm going to talk with you about vulnerabilities in smart contracts. This is a hot topic now, as you might imagine, because, well, it's about money, and the money is always interesting. And so let me start from the scope of the presentation. So I'm going to talk about not all of the smart contracts, not all of the blockchains, not all of the languages. So right now, I would say that here are listed the most, the most important smart contract blockchains. A big part of them is what's called EVM compatible. EVM stands for Ethereum virtual machine. So of course it's the Ethereum itself, it's a BSC, Polygon, Phantom, Avalanche, Optimism, and the main languages used to program smart contracts for the EVM compatible chains is Solidity and Viper. There's also a couple of EVM non-compatible blockchains, biggest one being Terra and Solana. They use Rust. So the scope of today's presentation is the following. I'm going to talk about only EVM compatible blockchains, namely about Ethereum, and there will be one case somehow related to Polygon. And I'm going to look at the Solidity examples. So let me explain first what is the plan. So I'm going to talk with you about what a smart contract is, and also I will tell you which tools and instruments do security analysts use, and also I'm going to present typical vectors of attacks and examples, cases, real world cases. So I'm not sure if I will be able to do that in time. I have 5 examples. Probably will cover 3 or 4, but if it goes well, maybe all 5. Okay. So let me first tell you about tools and instruments that I use. Of course, first and foremost is IDE, where you write your contracts. The standard de facto is it me? No. Your call ends in 10 minutes. Okay. So standard de facto is the one called Remix. It allows development of the contracts and compilation. Second one is Etherscan. Etherscan is a web service that allows you to check your transactions, and not only yours, any transactions on the blockchain. And what's more important, it allows you to verify the code. So let me explain that a bit. Smart contract essentially is just a piece of the code that is executed somewhere on top of the blockchain. So, and more than that, this is the code that works with, well, users' money. So how can you trust that? Well, usually for all major contracts, all major smart contracts, there is source code available. And this source code is put into this website, Etherscan, and then it is compiled there. And Etherscan verify if the source code that was submitted produced the same binary code that is on the blockchain. And that's how basically you know that, okay, the code that I see in the form of source code is actually the same contract that is deployed on the blockchain. I'll show you that later, how that works. Also, I think it's worth mentioning 2 instruments, one called Tenderly. It's also a web service that allows to debug transactions. It's very simple. You just open the website, you put in the transaction ID, and you get the debugger interface where you can step into, step over, and so on. Check for variables. Of course, if the contract code is optimized, you won't have good debugging, but still, it's something. At least you can see what's on stack and where are you on the chains of calls. And also there is a thing called Ganache, which is a small tool that allows you to make a fork of a blockchain. So suppose you found a vulnerability and you want to test it. Of course, you cannot test it on the mainnet, on the blockchain, because, well, you will steal someone's money or worse. So what do you do to check that your exploit is working? Well, you just fork the mainnet and you test whatever you like in this Ganache tool. Okay, so I have decided to make an issue classification. By no means this is, comprehensive. and full, but I think that's at least those two types are important. So one is how you can classify the events, the issues with smart contracts is by consequence. So there's a lot of different consequences, and more or less benign being like contract freeze. So what does it mean? It means that there's kind of error in the logic of the contract, and so user cannot, the smart contract cannot perform properly. For instance, user cannot deposit or withdraw their money, look for their balances or something like that. And it might be a reversible state. Next one is unfair advantage. This one is, well, basically, if you know something about smart contract and you are smart yourself, you might develop an algorithm, a way to communicate with the smart contract that will give you unfair advantage. Let me give you an example. So one of the, I think, best examples is automated decentralized exchanges. So imagine that you have a lot of people wants to participate in trade, and they all put their trades, their offers in the exchange, on the exchange book. And so sometimes if there is some kind of issue with code, you might prioritize your own, let's say, offer, and you will get filled first. Next one is money loss, so and money theft. So that it's a bit different. Let me explain why. So basically, money loss is the case when you have a contract freeze that is irreversible. So for instance, users' money are locked in contract, and you can't do anything about it. While money theft is, well, I guess it's self-explanatory when someone took users' money from the smart contract. And I also made this category called rug pull, which is, I think, also kind of an issue, maybe a trust issue, when developers of big projects purposefully, deliberately leave bugs in the code. So they, using their admin privileges or, I don't know, the bug itself, they can just take all users' money and send to themselves. That's commonly addressed as a rug pull. Next one, next categorization is by reason. And I think, again, it's not a full list, but I think I put the most important ones. So there is clearly sometimes issues just in programming logic. Someone made a mistake. Someone forgot to check something, or, I don't know, forgot to add one or subtract one, something like that. Second one is economical. By economical, I mean that smart contracts don't live in vacuum. They live in a very rich ecosystem. And so there are a lot of different actors there. So there might be some people who want to make arbitrage and again take unfair advantage of the smart contract. Sometimes it's not just you forgot to do something, rather you made a mistake in how you estimated the behavior of people acting with people interacting with your smart contract. Close to that is game theoretical thing. That's more about tokenomics. In other words, what are the incentives to, to hold the token or sell the token or exchange it to something else? And of course, I think the most actual big hacks falls into that category called ecosystem integration. So usually the problem with smart contracts is that the developer of a smart contracts makes a wrong assumption. Sometimes it's a wrong assumption about itself, the smart contracts code, but usually it is a wrong assumption about other smart contracts. So for instance, a developer might make an assumption that only user will interact with a smart contract. It might not be true. Other smart contracts can call your smart contracts. Developers might assume that the tokens, the other smart contracts that will be used inside the one developer develops, will behave according to its, to common sense. It's also not the case. And also, particularly important for smart contract is price manipulation and oracles. So for some smart contracts, what you need to do is you need to estimate the value of someone's portfolio, value of someone's tokens. And to do that, you need to have an access to open market data. And again, you might make wrong assumptions about validity of that data. So let me quickly summarize the important parts about what smart contract is. So of course, smart contract, first and foremost, it's a code. It's a code that works on top of the distributed system. In our case, our distributed system called EVM, Ethereum Virtual Machine. So no subjectivity. It means that contrast to normal programs that you have on your computers, smart contracts do not run in background. Smart contract never do anything by itself. It has hence no subjectivity. Any action that smart contract performs is only due to some user actually accessed the smart contract, call the method of that smart contract. So that's an important thing to understand. It's like an object. Smart contract basically in Solidity is an object that you might call methods of. Next, transaction atomicity. This is also a very important concept to understand. The act of accessing, of calling a method of smart contract is always encapsulated inside a transaction. A transaction is the same that you have like in Bitcoin, or in our case, it's just a simple Ethereum transaction. So what atomicity means? Atomicity means that whenever you call a method of a smart contract, the only two possible states you can end up with is either transaction is completed in full or reverted. So assume, let's consider some kind of a smart contract logic where first user A sends money to user B and then user B sends money to user C. If that's the logic that smart contract method implements, if when user B sends money to user C fails for some reason, a first part of the transaction also fails. So it's either success or revert. Next thing is ABI, not API. So application binary interface, not application programming interface. This is also an important part to understand. From the outside world, looking at the smart contract developed on a blockchain, there is no way to determine what methods does this smart contract has. So the only way to call something is to know the binary interface, not the programming interface. Programming interface will not help you. And one thing also worth mentioning is storage. So as you might imagine, every smart contract has to keep some information somewhere. So we call this place a storage, a smart contract storage. So let me give you an example. Let's say we have a smart contract that implements some kind of a token, right? And you basically need to write somewhere what is the balance of the user A, of the user B, of the user C. So where this information is stored? Well, this information is stored in storage. So where physically storage is, actually nowhere. It's a virtual thing. Smart contracts, for smart contracts, it's like a virtual space. They don't see that it's behind the abstraction layer of EVM. In fact, there might be no actual place where this state is actually saved. Rather, nodes in the network might just answer you to your questions. What is the, I don't know, the value of this particular memory cell for this contract storage? And they might calculate it on the fly. Okay. Now, let me get to the interesting part. So, I'm going to talk about some attack vectors. For each one, I will give necessary information, information to understand it, and I will also provide you with an actual case that had this kind of issue. So let me start from the beginning. Arbitrary code execution. Well, I think that sounds scary. So why does a smart contract will allow someone to execute an arbitrary code? So let me explain. So there might be legitimate cases for that. Cases what called zap in, zap out, and multiple actions. So imagine you have a contract that needs a particular token, let's say token A, but user only has tokens B, or maybe there's a lot of different users. Some of them have tokens B, some of them have tokens C, some of them, of course, have tokens A normally, but most of the people have, their liquidity in different kind of currency. So for better user experience, what you might do is you might write a contract in a way that it actually takes anything, not just token A, but any token, and then it swaps it somewhere to appropriate token. Sometimes it might be very long and very complex chain. So let's say you have a token C that is converted to token B, and only then token B is converted to token A, and these two conversions are done in different locations, in different smart contracts. So that's why sometimes you want to take data from user that basically says, okay, this is the route how you should swap our tokens. Now, let me explain what a ERC to ERC20 standard is. So basically, there is a lot of different standards in Ethereum. This one is describing the most basic notion of a token, fungible token. So in other words, you can divide it into parts. So if you had, I don't know, 1 USDT, you might transfer 0.5 USDT to your friend. So ERC20 standards is the standard that actually that tells a contract what kind of functionality this contract might have to provide. First of all, it's balances. You have to be able to look for a balance of a particular address. Transfers, transfer to someone, and allowances. Allowances is an interesting thing. So I think it's better if I show you the standard itself. I assume that everyone here is a coder and engineers, software engineers to some extent. So I think it will be easy for you to understand what's going on here. By the way, this is a remix IDE that I talked about before. So let's take a look at this interface. So you see, there's functions of course, without implementations because it's just an interface. And all of those functions has to be present in smart contract for this smart contract to be considered as a ERC20 smart contract. So let's take a look at them. They're really simple. Total supply, which just returns the total number of coins minted. Balance of, that takes an address and returns the balance. Transfer, that takes the address of destination and the amount. So note that there is no source. Why? Because, well, clearly we don't want to send someone else's money. So with method transfer, you only can send your money. Whenever you call a transaction, whenever you call a method inside the transaction, there is a special field present inside that transaction. This field called sender. And this field sender indicates who sent the transaction. You cannot, forge it. So for transfer, it is not needed to know from whom the transfer is, performed. It's always from the sender. So in other words, from the caller of the contract. And then there are those three methods: allowance, approve, transfer from. I just told you that, well, of course, you don't want to send someone else's money. But let's consider a situation where you want to, I don't know, put your money into an investment contract. So you put your, I don't know, USDT into a smart contract that, I don't know, puts them somewhere and gives you an interest. Because you can only call one contract and one method at a time inside the transaction, if that's the only functions we had, the only way for you to do that was to first call transfer and put a 2 as a destination contract, and then you will need to create another transaction to, I don't know, to make this contract to invest. Because when you call this transfer function, take a note, this is a function of the contract of the token, not the contract that we want, not the destination. So the destination will never know that it actually received anything. Because, again, as I told you, smart contracts does not run anything in background. So the only way to actually solve this problem, to be able to, transfer money to a smart contract and make smart contract do something, is this mechanism of allowances. So what does it do? Basically, you call the function approval first, and it says what amount of yours you will allow to spend for the spender. So you make a destination, you put a destination smart contract here first, and you say, okay, you can take, I don't know, $10 of my tokens. And then you can directly call the destination contract, because when you call the destination contract, it will see, aha, okay, I have an allowance from a user for this amount of money. And so if this contract inside needs to transfer this money, let's say from user to itself, the investing contract, it can call a thing called transfer from. So you see, in transfer from, the transfer differs from transfer from in this field, in this argument, from. So whenever someone calls transfer from and put here someone else's account, this function will check if sender actually have an allowance. Very simple. So it's like a way to say, okay, I trust you with spending my money, with transferring them to someone. Now, one of the one of the problematic cases here is that by default, the wallets that we use actually, when we call allowance, they offer to make an infinite allowance. In other words, put here the maximum possible value in approval. So why this is a problem? Let me come back to this slide. So, as I told you, the legitimate cases of this arbitrary code execution is when a smart contract wants to, perform a very complex steps of logic. And so, but you might ask, well, how does it work? Like, how precisely this arbitrary code execution works? Like, how do you achieve that? Well, there are two types of calls between contracts. So, first, let me probably show it. Let me open a, I don't know, any contract. So, for instance, here we call the deposit. When we, or better, better this one. Here we call function permit, or here we call function safe transfer from, of the contract called underlying, for instance. So, how do we call something? There are two types of calls actually. So one is a just simple call, and one what's called a delegate call. So as I told you, each contract has its own storage, right? So just simple plain call means that this contract will call this contract, and for this contract will be the sender, and all the actions in this method, of this contract, will be performed on top of this storage. But there is also a thing called delegate call, and well, you might guess from the name. So delegate call actually takes code from the destination and executes it on top of its own storage. And more than that, the sender for the code that will be executed here will be the person here, the source. Not like in this case, sender will be the contract. Here, sender will be the the previous step in the chain of calls. So, this particular issue with a thing called Zapper5. Zapper5 is the name of the project bridge. This particular issue was found by me and my friend. The amount of vulnerable money was about $2.5 million. We disclosed it to the Zapper and helped them to fix it. So let me now show you the problematic piece of the code. It's actually, I think it's quite simple to understand. Yeah, that's the one. So this is the contract. This is a contract itself, that the one that I'm looking right now. Let me Zapper-Matic Bridge version 1 subscript 2. So this one was a contract that allowed to transfer money from Ethereum chain to Matic chain. polygon chain. Sorry, Matic is the name of the main token there. So it was a simple bridging contract. So I told you, well, sometimes you need to improve user experience, so you allow user to give you anything, any tokens, whatever. So here we have a function, fill quote. And you see here even a comment, 0x swap. What does it mean? 0x is the name of the exchange, of the decentralized exchange, is the name of the contract of a decentralized exchange. So the developers thought that whoever will be using this function will actually be using calling to this swap contract. And so you might see from the arguments, you see here's a from token, which takes an address. So in other words, it takes an identifier of the token. Let's say some, I don't know, USDC. And there is, of course, an amount, and there is 2 tokens. So your target token, whatever token you want to have at the end of your chain of swaps. There's also a swap target. A swap target is the contract that you will call, and a swap call data is the data that you will pass to the contract. So let's see where we use that. Well, simply we use it here. So what does it mean? What does it say? We take swap target. In other words, it was designed to be 0x, but no one checked for that. And we call on top of this contract something with swap call data, which is also an argument here. So what's the problem here? The problem here is that we never check that swap target is actually an exchange. We never checked what kind of data we're passing to it. We also never checked what kind of token we are using. You see, we just give an address of the token. We cannot verify that this is actually like a legitimate token or something. So the problem here was that an attacker might concoct a particular call to this function that puts inside a swap target the address of a actual legitimate token and encode in swap call data call to transfer from. So imagine if this contract itself had allowance from user to spend user money. So what can an attacker do? Attacker know, okay, so this contract might spend user money. Of course, I cannot do that, but I can make this contract to actually call a transfer from for me and transfer funds of user to attacker's account. And so maybe I should introduce this side that basically this particular side was developed precisely at the time this vulnerability came out, because this side allows you to see all the allowances for a particular contract. And for this contract that are we looking at right now, there is no more allowances because, well, it was that was the issue. We asked people to withdraw their allowances, and by the way, for that, all you need to do is you need to call approve and put an amount 0. So you only approve it like a zero token. So yeah, that was the issue. So sorry, let me return to the code. Also, you might see there's some other calls. And I told you at the beginning that, well, that if any of these calls fail, the whole transaction fails. So it's not that simple. You can't just put, you know, as a swap target address of a token and a swap call data transfer from, method transfer from. You also need to put something, you know, something from token and to token and amount that all those checks will be successfully performed. And but again, as you see, there are no checks that this from token is like an actual, I don't know, let's say very legitimate token. And why is that? Why you can't check that? Because there's actually millions of those tokens. So you can't just whitelist them all. But what you can do is you can check that your swap target, the contract that you call arbitrarily, is actually one of the whitelists. And that's the mitigation of this particular issue. The second one, of course, is separate contracts that deals with money and allowances from the contracts that actually contains these arbitrary calls. So even if somehow hacker bypasses all your checks here, bypass your whitelist or whatever, and able to make a call to an arbitrary contract, you know, impersonating this contract itself will have no money and no allowances. So that will not become a problem. And also, that's the reason why a lot of contracts right now designed with that in mind, and we have vaults. We have a separation between logic that do all the stuff, investing, swapping, exchanging, whatever, and vaults that only has very, very reduced number of methods to transfer money and give you balances. Okay. Let's move on to the next one. This one is interesting. Integration issues and fallback function. So I told you how calls are works on a contract level, and I told you that there is no API, only ABI. So imagine that you have a contract with no how do you call it? With no source code. Let me give you an example. Actually, it will be hard to give you an example because most of the contracts are now have the code here. So what I'm showing to you right now is the following. This is the Etherscan, the website I mentioned, and I'm looking at the page of this contract. This contract actually is a wrapped Ether contract. And there you see there is a tab called contract, and you can actually see the source code of the whole contract. And also it provides you with those two things: read contract and write contract. So read contract allows you to call immutable functions. So you actually don't need to make a transaction to call an immutable function. So you can call name and you see, okay, that's a wrapped Ether, or you can ask for decimals, you can ask for total supply, and that's the exact value of Ethers minted, wrapped Ethers minted. So let's take a look at this contract. I have it here. So that's the original code. That's the code that is submitted on Etherscan, and that's the original code. And here is the code obtained from the same contract after it was compiled and decompiled back. For that, I used a website called the contract library. So if you see the address here, C00C00CON, it's the same one that we have here, C00C00CON. So this is a decompiled contract. And if you take a look at the very last function here, you will see it called function selector. So that's about that is how actually smart contracts interacts with itself, with each other, within itself. Each function, whenever you want to call a function, all you need to do is to know its selector. So what is a selector? Selector is just a 4-byte signature. How is it obtained? Well, that's how. Let's say we know that a particular contract have a function called transfer that takes address and a number. So we first take a Keccak hash out of this string, precisely this string, and then we take first 4 bytes. Now we get our function selector. That's precisely how smart contracts knows which function to call. So whenever we call a smart contract, first we go into this function. It's not a real function, it's a virtual function. It's only for purpose of the decompilation. It's not present in the actual code. But what you might find interesting here is that on the very bottom of it, there's a call to fallback. So what is a fallback? Fallback is a function that we call if no selector is present here. Does any contract have fallback? No, most of them don't. And what if there is no fallback? Well, that's a revert. So in other words, you're trying to call something that is not there, contract fails, your whole transaction fails. No problems. But let's take a look at the wrapped Ethereum. Actually, we have a fallback here. What does it do? It's not important. I can tell you what it does. Actually, you can pay to this method, like actual Ethereum, and it will be wrapped here in function deposit. But actually, function deposit does not check anything, does not do anything interesting. It's just takes the balance of sender and adds the sent value. You can send 0 here, there will be no problem. So this function never fails. Okay? Let's take a look at the problem. AnySwap Rota. The amount of stolen funds was $150 million. How? Again, let's take a look at the AnySwap Rota code. That's the first place we should take a look at. And the function that we are looking at is this one. This one here. Very, Java style name. Any swap out exact token for transfer underlying with permit. Now, so what is this all about? So remember I was talking to you about this approvals, allowance, and all this stuff. So what's the problem with that? The problem with that is that, well, you actually need to make 2 transactions. First, you need to give an approval to someone, to a contract to spend your money, and only then you can call a contract. So for that, there is a particular extension for ERC20 called permits. So there are just 2 functions, permit and transfer with permit. So what it allows you to do? It actually allows you to ask user off-chain to sign some kind of message, to sign a transaction, and then you don't need to have 2 calls. You can just make 1 call, transfer with permit. And for transfer with permit, the user needs to provide those 3 things, which represents the signature that actually verifies. Okay, so what is inside those signatures? Inside those signatures, actually a signed message that tells precisely the following: I allow anyone with this, signature to transfer my money with this amount until this deadline. So very very convenient. Now you don't need to call approve and then, deposit. You can just call directly deposit and, and pass this signature inside the deposit. What's the problem here? Look, there's also a function permit. What does this function do? This function do the very same thing, except it does not transfer anything. It only checks that the signature is correct. And if signature is incorrect, it reverts. Very safe mechanism, because whenever a call reverts, whole bunch of changes also reverts. The whole transaction reverts. Okay, so what's the problem? What could go wrong? Imagine that you use for underlying the contract that I just showed you, the wrapped Ethereum contract. This one. Look, it does not have a permit function, but it has fallback that never fails. So, whenever you pass this contract here, this permit will never fail. Because instead of calling the permit, they will be called the fallback, completely ignoring this whole bunch of arguments. And this call of this whole function will not be reverted. And so you see, the next line, save transfer from. So that's how you steal $150 million. Again, you look for all the allowances ever given to this contract for this wrapped Ethereum, and you just simply call it like that, without any second guesses. This check here, this permit here, supposed to revert your transaction, but it doesn't. So then you just steal other users' money. So is it a common problem? Not at all. As I told you, most of the functions don't have most of the contracts don't have a fallback. They just don't define the fallback, and so whenever someone is trying to call inexistent method, it will fail. But that was not the case for wrapped Ethereum. That was not the case for AVX. It was not the case for Matic tokens, and for all of those tokens were stolen from that bridge. And let's bring us to mitigation. Actually, there's no good mitigation against this type of attack. You just have to carefully check your assumptions about other contracts. There's no automatic way to check for that particular type of issue. And why it happened? Same as with the Zapper bridge contract. Unlimited allowances. People just assume, okay, well, it's a smart contract. Everyone uses it. My God, there is $200 million there. There are tons of allowances. It must be safe. So they just, without second thoughts, give unlimited allowance to whatever contract they ever, interact with. That's a problem. So,
One more question.
Yep.
Could you please show the previous slide with a slightly more explanation of the logic? What's happening? Because as far as I understand, we're talking about the balances of the bridge, right?
No, not the balances of the bridge, but rather this was okay. So this contract itself, Could you repeat the question for the listeners? Sorry.
We're talking about the balance of the bridge, right?
No, we are talking about allowances. So again, this contract, the bridge itself, doesn't have any balance.
Yes.
People give allowance for that bridge to spend on behalf of them. And so here we force, so here we have this check that says, well, is it actually true that this contract, that the caller of this function actually obtained a valid signature to actually, to spend the money? So the problem here is that this function that's supposed to check that the permission is correct, it's never called. Why? Because it does not exist in this contract, in this underlying contract.
Okay, so it's some kind of the malicious contract, or it's
No.
a bad design?
Neither. It's a contract that has fallback method.
Okay.
Lots of contracts can have a fallback methods.
Okay.
And so because of that fallback method that never reverts, never fails, instead of calling permits, the EVM, the virtual machine, completely ignores this whole arguments and just,
But as far as I understand, this is permit transfer from the
yes, from the
tokens contract, or not the tokens, from
No.
the sender.
No, from the user that we want to stole money from.
Okay.
So suppose there is a legitimate user A. Legitimate user A wants.
So, but
Yep.
the beneficiary of this call is the bridge contract.
This whole code is inside the bridge contract. Yes.
So this address, the second argument,
Yes.
is the someone who will receive.
No, address this. It's an address of the contract, not of the sender.
Okay.
So in fact, here we check that a user
Yes.
gave allowance, gave permit to transfer money to the bridge.
Yes.
And so if there is, if
okay.
user did not give that, well, of course, the bridge cannot
It's,
take.
on behalf of the bridge.
Yes. And then the following logic, it's not important what it do, but basically it takes the money that was obtained from the user we had a permit from and do something with it.
Okay, understood.
Yeah.
So this the link to this code will be in the slides, right?
It's publicly available on Etherscan. You can, I think that's worth mentioning. So, the thing about contracts are immutable. Once deployed, you cannot delete it, you cannot stop it, you cannot do anything without it. It's a blockchain. Once you have something on blockchain, it stays there forever. So, all the vulnerable contracts, all the hacks, all the transaction of the hacks are actually you can take a look at them in Etherscan. They will. Etherscan is an amazing thing. Let me find. Yeah, I think there might be a link to. How? Yeah, here we go. So you can take a look at the attacker's address. You see, Etherscan is even marking it as an attacker address. That it was, that was the guy who hacked AnySwap v3, and you can take a look at his transactions. You can even take a look at the very transaction where he stole the money. So, yeah. That's the transaction. You see the amount here, 300 and something Ethereum. And by the way, one Ethereum is like $3,000 right now. So, you know. Okay. I guess I have time for one more case. I think it's important to give you another perspective, because it's a very important, very important idea in DeFi right now. So let's consider a situation, right? You want to invest into I don't know, Microsoft. So what do? You buy shares from Microsoft. Say you have $1,000, and the current price of the Microsoft share is, I don't know, $100. So you can buy 10 shares, right? And then shares are, appreciating in price, and so now share costs 110, and so you get your $100 of profit. So one might think, well, why don't I manipulate the price? And in early days, that's what people do, actually. So what do? Well, you get, I don't know, you take your $1 million, bag of cash, you buy all the Microsoft stocks, it goes up, you sell on top, roughly. So let's imagine we are developing a contract that makes some kind of investment. Maybe it provides liquidity to somewhere, and that's how you get interest fee. Maybe it's a contract that actually, do this very, very intricate strategy of multiplying money by, providing to different pools and, recompounding interest fee and so on. It might be arbitrarily complex logic. Now, how do you develop this contract? Well, we say, okay, we are selling shares, and share of our contract is just basically a record somewhere that the user A has this amount of shares. And whenever user wants to withdraw their money from this investment contract, the shares burned, and the user gets his money back. Very simple. Now, what might happen? Shares pricing is, done by open market. So imagine user invests, I don't know, not stable coin, but rather some, let's say, Ethereum. And then Ethereum goes up in price. And this somehow affects user shares. Now, how actually open market works in DeFi, decentralized finance? So we have a thing that's called liquidity pool. So what a liquidity pool is? It's a very simple thing. It's a contract that has two tokens inside, token A and token B. This contract has reserves in token A and reserves in token B, and math of this contract is working that way that the dollar value of reserve of A and reserve of B are equal. So let's say a liquidity pool might consist of precisely one Ethereum and $3,000. It will mean that effectively, if you want to know a price for Ethereum, all you need to do is you need to divide reserves in dollars by reserves in Ethereum. Of course, if someone wants to actually exchange money and it, let's say, sells half an Ethereum, how does that work? Well, that works with something that called this curve. So here's the very, very simple formula. Whenever someone is trying to sell anything or buy anything from liquidity pool, it has to provide that amount of, that quantity of token X, so that the amount of token Y it gets will leave this constant unchanged. I think this graph explains it a little bit better. So this line is actually Y equals K divided by X. That's the graph of this line. And so right now we are in this position. We have this amount of token X and this amount of token Y. And now someone performs a trade and sells token X to this liquidity pool. That means that we go from here to here. So the amount of token X, of reserves of token X, increased, and the amount by which this function falls is sent back to the user. So you might think, well, this doesn't look too stable. I mean, imagine if it's only has one Ethereum and $300 and $3,000, and someone brings another Ethereum, and what will it cost now? Okay, it will cost half of it, 150, because of this math, very simple math. Well, let me show you some numbers. Let's take a look at this Curve.fi website, and we will take a look at the pool that consists of three stable coins. I think the most interesting numbers is here. Right now, in that pool, the total amount of money is $4 billion. It means that even if you put a million here, let's say in USDC, and take USDT back, this ratio will change insignificantly. And so you will have almost the same, price afterwards. But okay, that's a bit cheaty, because that's a stable coins. Let's take a look at something else. Let's take a look at something like Ethereum and some stable coin. So we will go to Uniswap v2, and we will try to find what is the current price for Ethereum. So the current price for Ethereum is this much. Let's take a look at this liquidity pool. It has USDC, which is a stable coin developed by Coinbase, and Ethereum. And the total value locked is, you see, 300 millions. So again, no problem. You can sell, I don't know, 1 million of Ethereum, and you will not get the price slippage. So, kind of okay. But there's always a but. What if you really want to manipulate the price? What do you do? Why not take a loan? Let's take a loan for $100 million. Well, if you have $100 million, you might as well, significantly shift the proportion. But there's not many of us who have a friend who can lend you $100 million. So what do? You have a thing that's called flash loan. What's a flash loan? Here's the picture. Remember, transaction is something that can either revert completely or be successful completely. What if some liquidity providers, some of those big pools, actually allow you to take their money within one transaction? So how does it work? They give you $100 million whatever $1 million. But you have to, at the end of your transaction, you have to somehow put it back with probably some interest, some fee. If you're not able to do that, the whole transaction fails. So there's no problem. But if you are able to do that, you actually have an access to an unlimited amount of money, almost unlimited amount of money. Lots of different liquidity providers actually provides this ability to take flash loans. So, and okay, so you might think, well, what is the interest? Let me tell you what is the interest. Interest is something like 0.006% on the amount that you take. So let's say you take $1 million, you have to pay 6,000 of commission. So if you can do something with this $1 million to gain more than 6,000, that's your profit. Initially, flash loans were designed to provide equal opportunity to everyone. So whether you are a billionaire or just a person who knows how to write code, you can access to money, and it's extremely simple. So let me just show you how it looks like in the code. That's basically it. All you need to do, you need to write a contract. All you need to do, you need to write a contract that actually implements this function, execute operation. And then you need to call a lender, a contract, smart contract of a lender, and give as an argument address to this implementation. And this lender will first transfer money to your contract, then call this function of your contract, and at the end, of course, it will check if it has its money back. That's it. So all you need to do is just write a contract, implement this one simple function. So I think I will not have enough fingers to count how many projects were exploited like that. Those are the biggest. This is around $30 million. This is around $50 million. This one is, I don't know, something north to $16 million or something. You can find it on specialized websites. So how this fail happens? Well, first of all, you provide user with shares, and the way that you determine the price of the share is by price oracle. And so if this price oracle is actually this liquidity pool, a malicious user, an attacker, might take a flash loan, manipulate the price so your shares will be worthless, buy a lot of shares, return the price back, and sell the shares. And so that's how this malicious user will drain money from your contract. So the oracles are subject to manipulation. Basically, this thing here, this liquidity pool with the money, it's called oracle. So what are the mitigations? Actually, that's a funny story. The thing is, for all of those guys listed here, all those methods were already known at the time. None of them cared enough to properly implement pricing. None of them cared enough to actually, to check whether their assumptions about how someone can change a price is correct or not. So what are the mitigations? Mitigation is really simple. A thing called TWAP, time weight average price. So instead of taking a current price, what you do is you have kind of running average of the price of the few previous blocks. So because with the flash loan you can only manipulate the price inside one block sufficiently, it will be smoothed out by neighbors. Next one, CEX oracles. CEX means centralized exchange oracles. So you can, there are smart contracts that built in a way that they can provide prices from centralized exchanges like Binance or, I don't know, Bitflyer in case of Japan, whatever. So, and because inside those exchanges you cannot manipulate the price, you will not have enough liquidity, you won't have $100 million out of thin air. So you cannot, you cannot push the price for sufficient enough time. And the chain link is the kind of solution. It's also a bunch of smart contracts developed by this chain link company that combines those two things. And this is also a standard de facto to, to get actual and unaffected prices if you need them inside the contract. Because whenever you need to price something correctly inside the business logic of your contract, that's the things you should use. So why all of those guys did not do that, I have no idea, but they all got, hacked. So one of the unpleasant thing about decentralized finance is that you actually it's really hard to distinguish between those two, because they did not price shares accurately. Was it a honest mistake, or they deliberately did that? You never know. So that's one of the problem with current state of affairs in decentralized finance: lack of trust. So some people say, well, code is the law. It means that whatever is written, whatever is deployed on the blockchain, it's a law. So if you deploy the contract with with this problem, whatever problem, that's on you, and it should not be regulated by third party. Some people say, well, it's I don't know, I lost my money, now I will call for a regulator, but I will not call for a regulator when I want to pay taxes anyway. So
the people who are counting on the regulator just have never had experience.
Yes.
Talking with the regulator.
Yes. So I guess that's the moral of the story. Trust no one. Do your own research. Read all the contracts you interact with. Never give unlimited allowance to any contract. Yes, it's not. It's not too convenient. You have to actually think, okay, I only want this contract to spend $100 of my $1,000,000, not $100 of my $1,000,000, not all the million, not infinite amount. So, but the problem is that this thing here, the most popular wallet, whenever you give an allowance, it does not, in UI, it does not provide you with an option to to make a smaller allowance. So
I have one comment that unlimited allowance is a very common used feature, because the unlimited allowance right now is a common used feature because it helps for the user acquisitions.
absolutely.
Because users are more interested to use just one single transaction
Yes.
for an action without two.
Absolutely.
So, and it looks like the scale of this problem that it should be solved on the contract level, because it's many things will not just work right now without unlimited allowance.
Yes, that's true. Actually, there's a lot of contracts that actually checks that you have unlimited allowance to itself, and it will not work if you don't. And so, of course, one of the way to solve that is this permit extension. So you don't have to call this approve function anymore. You just provide a permit, and permit is something that you just sign in your browser, in your browser extension, and that's the place where you can actually limit the permission. But there's only a couple of major tokens right now that are widely used that actually supports this extension. One being USDC. USDC, I think, is the only stable coin with a capital market cap higher than $1 billion that supports it. So that's an ongoing process.
One more question about the last attack. There was some time ago there also popular were the hard limits on the curve.
Yes.
Are they still useful, or there was some attacks that bypass this?
The problem with hard caps on the curve is that it's not it's not a viable solution from market perspective, because if you hard cap something, this thing immediately gets arbitraged out, because unless all of your markets are restricted like that, if there's another market that goes over this cap, there's a lot of arbitrage possibility. So you will either you will get drained all of your liquidity very fast, or if you have so much liquidity that you can actually suppress whole other market, then you will do that. But I don't think it's something that's economically viable. So yeah, I think this. I have two more cases, but I think I'm out of time. I'm sorry. The cases being the reentrancy issue and the unrestricted access. One of them was also for this project was found by me, and the amount of vulnerable funds was something around $5 million or something like that. So I disclosed this to the Synthetics team and got my bounty. So yeah, sorry. If you have any questions about my presentation, that's the time to ask. Sorry? Not a financial advice.
Okay, so going back to the permit issue.
Yep.
So that's, I think, requires a bit more information about the setting, because it was not yet clear from the source code what actually happens. So why this works?
Here?
Yes.
So okay, so let me quickly explain it again. So underlying here is the token,
Yes.
the token contract.
Yes.
If it actually had function permit, this function supposed to check if the signature is correct. If it's not correct, this function reverts. If this contract does not have the function permit, it is not implemented, then just the call to this function reverts.
Yes.
But in the rare cases when this token does not have permit function but have a fallback function that does not revert, this this line passes. So normally if you're trying to spend someone else's money, you will not get past this line because it will revert.
And the contract breach is authorized to make the transfer, right?
Yes, the contract, the breach contract itself, so the address this, right? It's authorized by legitimate users to, to transfer money on their behalf.
Okay.
And so if there's a legitimate user that for this particular token that have this issue gave an allowance to this contract, malicious actor can, simply force this bridge to take users' money and use them in some way beneficial.
So, from behalf of which, so the victim should be also the user of the bridge.
Yes, yes. Bridge itself is not a victim here. Rather, bridge is like an actor,
yes.
with a
The authorized.
yeah.
Bridge is like a bridge.
Yes.
Yeah.
The security design of this contract is very. So they rely on the code of the random contract.
Yes, precisely, and yeah.
What can go wrong?
Yeah, precisely. What can go wrong, especially if you have $100-something million? And people, I mean, this is a funny part because people actually tend to trust contracts with this huge amount of money, with this huge allowances, because, well, if there's so much users trust that.
The most pleasant part here that many developers of the smart contracts tend to trust to the code.
Yes.
Which has a lot of money.
Yes. Yes.
And it's sometimes it's quite difficult to make them understand.
And precisely, and you see, I think that's precisely the reason we have this many hacks right now. Because while the developer of the contract itself might be well aware of the culprits of the design of the contract, of his contract, but in no way this developer can be, certain about the whole rest of the, ecosystem. So you make assumptions, and those assumptions turn out to be wrong. So again, no one prevents you from developing MyQL ERC20 contract and put whatever you want inside the transfer from function, whatever you want. You don't actually need to have a balances of the user. You can put whatever you want, and if you provide this contract, if you provide this address to this contract inside, I don't know, this bridge or other contract, basically you will have a call to your code where you can do whatever you want. By the way, this was an example for the reentrancy issue.
Yes.
There was this funny little function, deposit4, that has no reentrancy guard check. It allowed to call, user provided token, and it took balance before the transfer, which is a big no-no. So what this malicious transfer from function of the malicious token did, it just repeatedly called this contract again and again and again and again, and every time you had the same balance, and then yes, you actually put the balance, and all this calls in this chain will see as if you put in each of this call this amount, not one. And I mean, again, funny thing is that this particular hack was the first big hack in Ethereum. Maybe you heard about it, the DAO, Decentralized Autonomous Organization. In 2016, they lost around $240 million. And actually, at that time, that led to split in Ethereum. And so we had Ethereum and Ethereum Classic. Ethereum 1 being the guys who reverted that transaction, and Ethereum Classic the one that said code is the law. So we now have two Ethereums. Anyways, and this is a code from 2022. This particular hack was on Phantom blockchain in January. Lost $60 million. So,
I know it's like kind of like outside of the scope of your presentation, but
So, what's the question?
like for example, what do you think about Solana or other non-Ethereum blockchains? Are they any safer than?
Okay, so that's yeah. I guess you're talking about those guys. So the problem is, they don't have as much money as those guys, so they are not as interesting as those guys. As soon as they get the amount of money, let's say Ethereum has, or at least Binance Smart Chain, they will get hacked. In fact, there were already some issues with Solana and some Terra, but the amount of funds were I don't know, $10 million. It's nothing. So yeah, I think that there's this funny. Let me. A website that tracks all the guys who got hacked, called Rect, you know, and I think it does a very good job. So you see now the whole Polygon network was hacked for, you know, this much, and yeah. Look, that's one of the issues I told you about, and I think the very important thing here is that it also most of those projects were audited by smart contract auditors. That tells you something about the quality of the audit. There is no single audit company who gave an approval to a contract that was not hacked. No single audit company. Like even big one like PackShield or Certic or whatever, you can find them here. So, yeah. Okay, thank you very much. Okay.
Okay, thank you, Andrei. Very interesting presentation, and I think we can talk a little bit more about it on future conferences.
Yeah, I'm sorry.
See you again on the next Moment conference, for example, and yeah, we will definitely get back to this topic and talk maybe some more detailed cases. Thank you for this presentation.
Thank you for your attention.
So we also have a workshop today, also presented by Andrei, another Andrei. So now we will take a small break, 5 minutes, and set everything up, and we will see you at the workshop. So our next topic is a workshop by Andrei Enshin. So this is more practical task, so you can actually follow along with the presentation and his instructions and practice it at home on your PC and get some valuable practice experience. So please welcome Andrei with his presentation, and let's start.
We have a lot of people. Первый слайд. Меня зовут Андрей, я работаю в Rakuten. Ваташино намаева Андрей дес. Different language. My name is Andrei. I'm a Rakuten engineer, and I'm gonna speak about rather fourth time today. Okay, so everyone has access to lab server. You can do it from your laptop if you have Radar installed. Okay, I assume you have. first use case is as a hex editor. I usually hear questions: what is a hex editor in Linux? Which should I use? Usually people don't know what to use. They use Vim plus hexdump or some other tools, but there is no good answer. For actually Radar, if you check history and in Radar book, was developed as a hex editor initially in 2006. So we can use it as a hex editor without debugging, without disassembling, just as very basic tool. Let's do it. Here is a file in your home folder. The file name is case1hexeditor.png. If you run command file against it, you will see that it is data. File command cannot recognize it as a PNG image. It's a broken image. So you can try it. We're gonna just restore this file. So very basic task. Usually you can find it in CTF. How to restore it? We just need to open it in the Radar and modify. Let's do it. Open this file in Radar, provide -w option, and this file. So you will get something like this, which means you are ready to input your commands. So you are inside Radar. Next, you just need to enter to visual mode, type big V and press enter. You will see something like this. It's a hex dump of this file. You can move around by H, G, K, L keys. You can enter to cursor mode by pressing C. So if you press C, you will be in cursor mode. And you can use tab to switch between hex representation and ASCII representation. You can press I for insert mode, escape or Q to stop editing. But it will work only in hex pane, so you need to tab back. And question mark for help. So you must be like this. You must see such. So please do modify it to PNG. Change LOL to PNG. That's what I did. I just corrupted this file by myself. And all changes will be saved to file, back to file. So we just did restore PNG. So very basic task, very basic idea. So you can use Radar as a hex editor. You can edit any byte in your file. Any success or any difficulties with this task? So finally, we can save Panda. This is our PNG which was initially broken. So let me do it in my screen. So I just do open the file. I press big V, not small, but big one. I can see this view, and I can see LOL. I press C to enter to cursor mode, so I can move around by here. Then by tab, I can change between ASCII view and hex view. I'll go to ASCII view. Then I press E to change, and I change to PNG. That's it. Then I need to come back to hex view by tab and exit. Oops. I did some mistake here, but anyway, then we will quit. So this is first task. This is what you can do with Radar. You can use it as a hex editor. Next task is disassembler. We have a simple crack me. The crack me has a It's just a binary file which has name guess pass. You can run it inside lab and enter any password. Just try to guess it. So what we will do, we just open Radar in Radar this file and see in disassembler. So basically just R2 and file name, nothing else. Next, you can enter to disassembler view, visual view by by small v, and you will see something like this. So you will see disassembled code of our binary. Next, we will seek to main function. There is a command seek, short S for this command. Just seek main. To enter to command mode, just use colon. So to switch between visual mode and command mode, it's like a Vim-like editor, Vim-like tool. So then you can seek to the main, and now you can see the main function. I hope you can see it. And in the main function, you can see simple strcmp call, which compares your input to hard-coded password. So it's very, very basic thing. So the password is my secret password. So to double check it, you can go to section RO data by also command seek, and you can see all strings defined in this file. So you can see enter password, my secret pass, correct, and nah. Let's verify this password is correct. Just run this crack me, enter password, it's correct. So we did crack, very, very easy crack me using Radar. If you have any difficulties, let me know. We're gonna move to our third use case as a debugger. Next use case is a debugger. So we did hex editor, we did disassembly, and now we will do debug. We will run this program and run it step by step. Here is a simple crack me 2. It has name guess pass -2. Let's try old password. It doesn't work. So let's see in raw data. This time there is nothing in raw data. So password is somewhere else. We cannot guess it very easily. Let's seek to the main, and we can see that there is inside main function some strange obfuscated password, but it doesn't work. I tried it, obfuscated pass, try me, I'm wrong. It is really wrong, it really doesn't work. Let's see into logic of this program. So there is a lot of instructions, and I'm too lazy to reverse them. So we just simply don't want to understand the logic, how to obfuscated password became real password. What we want to do, we want to put a breakpoint between comparison, between strcmp and look into memory. Very easy task. Let's run this second crack me inside Radar, but this time provide -d option. It means debug mode. So we will debug our binary. At this time you will be at some address. It's linker, I think, Linux linker. So that's why we need to continue execution until main. This time it's not seek, but dcu command. Dcu command, D stands for debug, C is continue, U for until. So continue until address. By the way, each command has help if you add a question mark to it. So let's continue execution until main function. So just run dcu main and you will come to main function. And then come back to visual mode. It's much better to see what's what is around. So we are here. We can see our stack, registers, and disassembly. Next, let's go to command mode and search for string correct, which we already saw. We've seen it in RO data section. So we just need to search for this string inside our binary, and it's easy, just backslash space and your string. It is found, and then you can seek to this hit, to the string, just as hit 0. By the way, there is auto-completion by tab. If you put high and press tab, it will give you. So here we can see that there is a string at this address, the string correct, but nothing more. What should we do next? The next, we can ask Radar to analyze our binary and find where this string is used. So probably the string is defined in one place but used in another place, somewhere in our code. So just run AA. A stands for analyze. You can run 1A, 2A, 3A. It depends on how much you want Radar to analyze your code. 2A is enough. So you will get, and then come back to visual mode, and you will see there is some comment which Radar put it. It means that the string correct is used inside main function at this address. So we have a hint from Radar. Then let's go to this address and see how the string is used. So just use command S and put this address. In your case, address will be different, I think. So you must see this assembly. It means that we will get correct answer if strcmp of memory located by address which we have in RSI and RDI are the same. Otherwise, we will have nah. So our target is to explore what we have inside RSI and RDI before comparison. How to do it? So how to do it? We just need to put a breakpoint on strcmp call, so we can explore what we have in RSI and RDI. So to put breakpoint, there is a command db. So D stands for debug, B for breakpoint. So just put address of strcmp instruction. In my case, it was B1A. In your case, it might be any other. So if you put db, and then you can run. C is just continue execution. So it will run until this breakpoint, but program itself will ask you for password. So you can enter any password just for to continue program execution. Then you will hit breakpoint, and you can come back to actually you can stay in command mode. So when you hit breakpoint, we can use a print command. There is a print command, and print command has sub-commands. PS means print zero terminated strings. So what we want to look at our password, and password must be a string. So let's run PS at address pointed by RSI. It's deobfuscated path, try me, I'm not wrong. Okay, sounds much better. And PS RDI points to what we inputted before, 1, 2, 3. So let's try. Yes, this password is correct. So that's how we can use a debugger of Radar. If you're interested in this tool, it's a very basic tool. If you like Vim debugging, you definitely must be interested in this tool. Join this Telegram, ask questions, and thank you.
This is it for our today's conference. So thank you for participating, and The video recording of the conference will be later posted to YouTube, and you can check it there for any videos or presentations you missed. Our next conference will happen in 3 months, so around May. And any future information about this conference will be posted to Telegram, Instagram, and other channels, so you can check there for future announcement. And thank you for joining us today, and see you on the next conference.